So this is 2.19 um, for physics final, 2.19 till 2.23. They're very easy and it's a good page and 2 pages يعني. Two pages and 3 pages. Okay, I think more actually. Yeah, 4 pages. Okay, المهم we'd get it done. I'd say in 40 minutes. Okay, where's my open word? Okay. So, when an electric immersion heater is connected to 110 volts main supply, a current of 50 amperes flows through it. The water tank contains 100 kilograms of cold water at 30 degrees Celsius. They want us to calculate the temperature of the water after 1.0 hours. Assume the tank itself has no heat capacity and is perfectly lined. Okay, so here we're talking about heat capacities, talking about I and V. Okay, if you see this question, which I think might come in the computer, okay, remember that power is equal to IV. Remember, and Q is equal to MC delta T, right? Also remember that Q is equal to power times time, right? Remember, energy is equal to power times time. Q is the same as energy. Remember, Q is equal to MC delta T. Remember, power is equal to work over time. This is the main formula for power. So work is the same thing as energy or Q because these are all measured in joules, okay? So in other words, you can say Q is equal to power times time if you remember this from chapter 1, guys. So basically, here, remember, P equals IV, okay? So also remember the formula, guys. IVT is equal to MC delta T, if you remember this from chapter 1, okay? So here, basically, we're going to use that. It's very easy, okay? If you see IV and then you see heat capacity, you use the formula IVT is equal to MC delta T. I is 50, V is 110. Time must be in seconds, 3600 equals MC delta T. The mass is 100. The C is 4.2 times 10 to the power of 3. And the delta T. Delta T is final minus initial. Okay, so temperature final minus how much is it initially at? 30 degrees Celsius. So you can just solve this. Just to save myself time, I'm just going to put this into a calculator. 50 times 110 times 3600 is equal to 100 times 4.2, which is 4200, times x minus 30. And the shift solve. Okay, so we got 77, and in the course division, it's also 77. If you round it to 2SF, it's going to be 77, okay? Because 2SF. A 15 ohm resistor is connected across a 24-volt power supply. What's the power dissipated by the resistor? Remember, P is equal to V squared over R. So it's going to be 24 squared divided by 12, which is, wait, 15? Ah, okay. How did I get 12? Sorry, 15, guys. And you will get 38.4. Okay. 25 ohm resistor is connected across a 10-volt power supply. Calculate the energy in 30 minutes. Remember, always energy is equal to power times time. Okay, this is always correct. Okay, power is equal to IV, and the time in this case is T, right? Okay, IV is, sorry, I don't know why I'm using IV. Power equals IV, but in this case, I don't have I. So what formula are we going to use for power? We have R and V. We're going to use V squared over R times T. Okay, because the power is V squared over R. Okay, you need to always know energy is power times time and ask yourself, what do I have? What formula of power can I use? Okay, always. V squared will be 10 squared over R, which is 25 times the time. The time must be in seconds. So 30 times 60. And I guess they use the same thing. V squared of RT, 10 squared over 25 times. Okay, you got this. What is the difference between a rheostat and a potentiometer? Remember that a rheostat controls current. Variable resistors are called rheostats. Okay, however, a potentiometer is a three-terminal variable resistor, but a rheostat is a two-terminal variable resistor. Okay, you can use any of these. Okay, you could say the first thing, I guess, and maybe if it was a 2-mark question, variable resistors are rheostats or potentiometers, right? Remember, if you remember in my notes, I need to make a document linking all of them. Basically, if you remember in my notes, I told you that resistors can be fixed or variable, and variable resistors are either rheostats or potentiometers. Don't write what I did here. Okay? So they're both variable resistors. But what's the difference? Okay? A potentiometer is a three-terminal, but a rheostat is a two-terminal. If you remember in my notes, come on, I drew it for you. Potentiometer had three terminals, one X, Y, Z, and rheostat was just one terminal, one here, one here. You drag it along. Okay? Potentiometers are often used, and this is also important. This would be a 1 mark question. That could give you, sorry, 1 mark. And here you could say potentiometers are for voltage, rheostats are for current. That's another mark. Okay? So, yani, to summarize, say potentiometer is three terminals, rheostat is two. Potentiometers are for voltage, rheostats are for current. If it's 1 mark, I would write this one. I don't think I'd remember this in the exam. But, like, yeah, this is a potentiometer. One, two, three. And so small. This is the, yeah, this is also a potentiometer. Okay, this is over here. Okay, this is a potentiometer. You see how it has three? Okay. A potentiometer is connected parallel to a voltage source as shown in the diagram below. The schematic diagram of a potentiometer is also shown. An IGCSE student needs an output of 3 for an electric motor that she constructed. Where should she place the wiper of the potentiometer? She needs 3 volts. With a potentiometer, you drag your scale, you drag your wiper according to where you want the volts. If you drag it all the way over here, how much do you think the circuit will be giving you? It will be giving you uh, 6, right? Wait. Yeah. So you see, this is V out, right? If you drag it all the way up here, you'll be getting 6 volts. But if you drag it down here, مثلا, you'll be getting 0 volts. Okay? So it depends on how much you're using of the potentiometer. So if I want 6, I have 6, and I want to get 3, obviously I'm going to place it halfway, and halfway would be zero point 0.2, right? So it should be over here. Let's see the answer. When the wiper is set at 0.1, it's 0, right? When it's at 1, it's 0. You need to know this, by the way. When it's grid questions, I'm going to stress on them. You need to know them. 1, it's 0. 0.3, it's 6, right? Equal to 6. Therefore, for the student to get 3 volts, she must play it halfway or midway between 0.1 and 0.3, and in this case, they should have said 0.2. Draw a labeled circuit diagram showing all the apparatus necessary to find the characteristic of a filament lamp. If you remember the characteristics of the IV graphs, they're all in my notes, which again I suggest you to read over or watch the video. But the characteristics for the filament lamp is that as it moves up, there's less current, there's more resistance, and as it goes down, there's less resistance. So basically, whenever you're checking the characteristic, I'm gonna stop yapping. Whenever you're checking the characteristic, you're talking about the IV, okay, and R, okay. So for these three, how do you check the I? Ammeter. How do you check the V? Voltmeter, right? And the R, we're checking the resistance, so you just add any resistor. How they did is just copy how like in case it comes, copy this here. Basically, they started with obviously you need a cell, right? I'm gonna draw it here. You don't need a battery, but yellow. Okay, you go down, and we know we're measuring the current, so the ammeter should be in series. What are we measuring? We're measuring a filament lamp. I'm pretty sure you guys know that this is a filament lamp. Okay, and again, we want to check its voltage. The voltmeter must be connected always in what? Parallel. Okay, always. طيب, you checked your ammeter, you checked your voltmeter. What are we missing? We're missing the resistance. Okay, so I'm gonna draw it like this. This is my resistor, and it has the arrow over here, and it has like the box. Hold up. Shit. It should be. This is the resistor. Okay, you know what? I'm just gonna copy their one. I guess yeah, you could copy their one. Um, it's completely fine. You can take so if you take it up, you have this over here. Okay, let me draw it one more time. I messed up. This is the positive terminal, negative terminal, whatever. You go down. You want to go down. Put your ammeter, right? Then put your lamp. voltmeter. Okay, then you put your resistor. Okay, and then hey, hold up, hold up, I'm tweaking. Yeah, and then you put this here, is your resistor, and then you take this over here, right? And you connect it. Basically, this is here your cell. This is my potentiometer. Because enter you're seeing I and V. You're controlling the voltage. You always need a potentiometer. When you're studying the characteristics, you're checking the IV graph. The IV graph, basically, we're checking what happens as voltage increases. And how can you change voltage? You need a potentiometer, right? That's why we put a potentiometer. Okay, and this over here is voltmeter. Because you have to label. I don't know why I didn't label. This is ammeter. And this over here is filament lamp. Okay? So, summarize. If you ever want to check the characteristic of something, you draw a circuit containing that something and always add a potentiometer. Potentiometer looks like this. Okay? If you want, you can just copy this circuit. I don't know why they didn't label it. They should have said, they should have labeled it here. What happens when the resistance of the filament, what happens with the resistance of the filament lamp as current increases? You remember filament lamp, and I'm not going to explain. They're all in my notes, and if you want, you can read the book, يعني. But everything's in my notes. Again, if you're in the WhatsApp group, I'm gonna make a file containing any all of the videos that you may need to watch. Um, draw a labeled. Sorry, what happens when the resistance of the filament lamp as the current increases? Remember, the filament lamp looks like this. Okay, هيك. Okay, here the current voltage. As you're going up, the current kind of starts to go down. Okay, that's because the resistance starts increasing. When there's more resistance, basically it's telling the current, no, you have to go back down. Okay, so the resistance will increase as current increases. Okay, the resistance increase. Is the film lamp an ohmic conductor? No, right? Why isn't it an ohmic conductor? Look at its graph, right? It's curved. You can't have a curved graph. An ohmic conductor is one that obeys Ohm's law, right? It doesn't obey Ohm's law since its resistance is not constant. It has to be a straight graph. Okay, like this. Look how it looks. Okay, it may be straight over here, but at its ends, it's not straight. Okay. Here. What is component X called? It's called a diode, right? It's a diode. And what happens in the circuit when the poles of component X are flipped? Obviously, it becomes open. The current will stop flowing, or you can say it becomes open. Basically, this, it's one way. Okay. So basically, يعني if إذا you're pushing it like this, it's gonna take the current over here and it prevents the backflow. Okay. طب let's say أنت جيت, you're like, yo, let me make it like this. Okay. هيك, see this pole here? The current's gonna come here. The pole's gonna be like, no, you can't pass, and basically the circuit stops operating. Okay. So if the diode is flipped, the circuit becomes open and current may not pass. 57, draw and describe and draw the IV characteristics of each component. I'm going to just go through the answers, okay? An ohmic conductor has a straight graph, okay? The current through an ohmic conductor is directly proportional to the potential difference across the ends. If the temperature and other conditions are constant, la 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 la. Okay, just memorize that ohmic conductor is a straight line passing through the portion. It looks like this. Okay, it's straight. It obeys Ohm's law. Remember, when something obeys a law, that means it's a straight line passing through the origin. That's not passing through the origin, but you get me. Okay, then what do we have? Filament lamp. Always at low currents, the characteristic of a filament lamp is a straight line passing through the origin. I told you, filament lamp, for the most part, obeys Ohm's law. But as current begins to increase, resistance begins to increase. You see over here, okay, more heat will be produced and the temperatures rise. Temperature rise will increase its resistance and the slope of the characteristic curve decreases. Okay, memorize it. Okay, then we said the thermistor. Thermistor. The thermistor has an NTC, right? Basically, and how I memorized it, the thermistor, I memorized the filament lamp. Then I was like, yo, you know what? the thermistor is basically the same thing, but opposite. So instead of going down, it just goes up. Okay, and over here it goes down. Okay, that's how I memorized it. So it has the NTC whatever, basically means that as current increases, instead of the resistance also increasing, what happens? The resistance actually decreases. Okay, so which means that its resistance decreases as temperature increases. By the way, the reason for resistance increasing here is because as current increases, you have more particles flowing, which will cause more friction, which will increase the temperature. And you know, when temperature increases, more resistance is happening. But what does the NTC do? The NTC, you can kind of think it as the NTC has autism. Okay, the NTC, it's negative. Basically, it doesn't understand. It's backwards. It goes like, yo, what temperature is increasing? Instead of giving you more resistance, I'm actually gonna give you less resistance. Okay, think of it like that. It's negative, so it has autism. So instead of the resistance increasing and the current going down, the resistance actually decreases and the current goes up. Okay, so the slope of the characteristic curve increases. The semiconducting diode. The semiconducting diode, this is the only one that looks like this, okay? Diode exhibit very high resistance in one direction. That's why we call it unidirectional, okay? And low resistance in the other. You see over here, it has high resistance. Sorry, no. Here it has high resistance. But here it's low resistance because there's actually current flowing, okay? A diode is nearly ohmic, but in the reverse direction, very small current flows. So here it's nearly ohmic. You can see how it's almost straight, kind of, okay? But over here, he's barely exhibiting any current, okay? Resistors of resistance 2 ohm and 4 ohm are connected in series across a battery composed of 1.5 volt dry cells. An ammeter shows a current of 0.5. What is the total potential difference applied across the circuit by the battery? Remember, people will be tricked, they're going to put 1.5. But here's the thing. No, obviously not. The whole thing is that it's in series. And remember, in series, the voltage isn't the same everywhere. Okay, so for that reason, you actually need to find it. We have resistance and we have current. So we can do V equals Ri. Okay, but here's the thing. Resistance in series, you can simply add 2 plus 4, right? So it's going to be 6 times the current, 0.5. So you're going to get 3.0. Okay, volts. What are the possible arrangements of the cells in the battery? I guess like this. And is that the answer? 1.5, 1.5. Series combination of any number of cells in parallel. Parallel combination of series pairs. The parallel combination of what? Okay, wait. I think I get this. Series combination is the one I drew here. Okay, this one. This is series. Okay, remember, like if you had 1.5, 1.5, right? A parallel combination of series pairs. So basically, it's pretty much the same thing. It's literally what I just said here, but you just swap the words. Nothing different. The parallel combination of the first. You see, this is what I don't get any. What the what? What's the parallel combination of the first two? I don't know. But I think they mean first two as in these. This is a lot of yap. But I guess if you understand, it's just the words, man. It's not an English exam, it's physics. You should just know the word. You should just know how to draw it. I guess you can say. Uh, uh, wait, what am I drawing? Hold up, no, this is correct. If I put it here, yeah, okay. A 1.5 volt dry cell is connected to a small light bulb with a resistance of 3.5 ohm. How much current flows through the bulb? I is equal to V over R, right? V equals, yeah. Okay, and therefore, you're gonna get 1.5 over 3.5, which is, I don't know, should be repeating this one. Yeah, 0.43. A current of 6.25 ampere flows through a microwave oven. If the resistance of the circuit is 17.6, what is the voltage drop? I think here they're just testing us across Ohm's law. Uh, R is 17.6, 6.25. Let's see, is that correct? Yes, 100. These are very equation. I hope the whole exam comes from these. Okay, these two always come. What's the equivalent resistance of the following resistors? If they're in series, you can simply add them up. So you're simply gonna get 90, I think. 90, yes. 15 plus 25 plus 50. What's the equivalent resistance of the following resistors? If they're in parallel, you have to do 1 over R is equal to 1 over 10 plus 1 over 15 plus 1 over 20. So you're gonna add these up, okay, and then you're gonna flip it. So basically, okay, 1 over 10 plus 1 over 15 plus 1 over 20. And then this 13 over 60, you're basically gonna flip it. Okay, so you're gonna do 16 over 60 over 13, which is whatever. What's this? 13 over 6. Yeah, they get this right, and then you get 4.6 because they flip it. This -1 basically means flip. 62. You have to use distance of resistances R1, R2, and R3 in the diagram. Okay, calculate the voltage across R1 and R2. Okay, across R. Oh wait, no. Okay, they told us. Okay, ignore this 12 here. I don't know why. I feel like I've solved these on my channel before. Wait. Ah, yeah, solved this before. I'm saying I solved these questions. Yeah, خلاص. I mean, I guess I'm done. Where did I finish here? Yeah, I just did the quote. Ya Allah. Okay, man, I guess I'll do it. خلاص مش I remember it now. Okay, so they give us the EMF is 4.5. So here, instead of 12, it should be 4.5. Calculate the voltages across R1 and R2. Okay, first we know this is 2, this is 4, and this is 9. Into, V is equal to Ri. So first we should know what's the current passing through here. Okay. Before continuing, voltage here is 4.5 and the total voltage here is 4.5 because these are parallel. Remember, parallel circuits, they're the same voltage, okay? So I don't confuse you. Anytime you see a question like this, you need to find the current, okay? Because V is equal to Ri. Okay, عندك resistance but you need the current, okay? Some people might put 4.5, 4.5. طب كيف 4.5 plus 4.5 تطلع 9. Now we know the total should be 4.5, not 9. Okay, V is equal to the resistance. Total resistance, uh, sorry. I'm talking for the whole, yeah Allah. V is equal to Ri, right? We need to find the current. To find the current, it's going to be equal to V over R, okay? In this case, I'm talking about the whole circuit, okay? Because when you find the current for the whole circuit, عادي بتزبط, okay? I is equal to V over R. The voltage is 4.5. Resistance, 2 plus 4. Here in this branch, you have 6 ohm, but it's in parallel with this 9. If you want, you can use the rule 1 over 6 plus 1 over 9 and then flip it, or some people either use the product over the sum, okay, which works completely fine. So they get 54 over 15, which is عادي يعني, it's fine, okay? I'm gonna use 54 over 15, okay? 54 over 15, okay? So I'm gonna get here 4.5 over 54 divided by 15. I'm gonna get 1.25 is the current, okay? So I is equal to 1.25. Sorry, and what am I doing? Why am I finding the I for the whole circuit? I should find, ya Allah. Sorry, huh? And then when I found I here, I got 1.25. This is for the whole circuit. And I should دخلني بالfull circuit. I should find, remember, we're talking about R1 and R2. So I should actually find the current that's in this branch. Okay, so see now you know what not to do in the exam. Okay, so you need to find the I in this branch. Remember, V equals Ri. Like I told you, why am I finding I? Because I need to find the I so I can find each voltage, okay? To find the I in this branch, same thing I just did, but just use a different number. I is equal to V over R, with the voltage is 4.5, right? No, not 12, it's wrong in the picture. The resistance, we're talking about this branch. If this is 2 ohm, and this is 4 ohm, it's 6. So you're gonna get 0.75. Okay, so you get that the current now is 0.75. So now you can solve for each one. V equals Ri. Here it's 2. V equals 2. The R is 2. With the current, how much is it? 0.75. So you get 1.5. Here V equals Ri. The current, the resistance is 4, right? With the current is again 0.75. which is um 3.0. Okay, so V1 is 1.5, V2 is 3.0. Let me see. Yeah, okay. Why I found the current again is because you need the current for V equals Ri. So why I found it for this branch is because remember the current here is equal to the current here. Okay, why shouldn't I find it for the total circuit? Think about it like this: analyze, try and understand your circuits. Okay, current will flow from the positive direction over here, go down. Over here, it starts as I and it splits into I1 and I2. So for that reason, if you find the I, you're gonna get 1.5, right? Or whatever it was, 1.25. Okay, but this is for here. أنا شو دخلني بالهيدي? I don't care about this. I care about what goes into this branch. So I can do V equals R times I. Okay? Section 2.23. 500, this is shunt resistance. 500 ohm, 1 milliampere ammeter is to be made into an ammeter that can read up to 5 ampere. Determine the shunt resistance. Always remember RS is equal to IFS times R of the coil, R of the coil over I minus IFS. Okay, this is the shunt resistance form. I think, let me just double check this. Yes, okay. So you're gonna get IFS, it's the full scale resistance. Always the full scale resistance is the small one. Okay, it's the one that goes to the galvanometer, because remember the galvanometer can only hold, remember the ammeter is composed of a galvanometer. That galvanometer can hold very low current. Okay, so this current, it's full scale. This is what we call the full scale current. It's the one that passes through the galvanometer. It's always the small one. Okay, so 1 milliampere, remember it has to be ampere. So we're going to change it to ampere by multiplying by 10 to the power of negative 3. Okay, or dividing by 1,000, whatever. Times R of the coil. The coil is 500. Always, the R of the coil is very high. Okay, it's very, very high. Then I minus IFS. I is the big current. IFS is the one we got in the previous part, or up in the numerator, and you're gonna get 10 to the minus 3 times 500 over 5 minus 10 to the minus 3. You're gonna get 0.1. Okay, into two significant figures, so we're gonna put it as 0.10. And since you're talking about resistance, it has to be ohm, right? Let's see, 0.1. Okay, whatever. It should be 2SF, huh? Okay. An electric loader used to lift weight operates at DC voltage V equals 24 and current I equals 3.2. Determine the power drawn by the loader. Power is equal to, we have I and we have V. Yeah, P is equal to IV, right? So you're going to use 24 times 3.2, which should be 80 or something like this. 77, yeah. Okay. The efficiency of the loader is 80%. Determine the power output of the loader. If it's 80%, يعني 8% of, نحن we got 77, in 80% of 77, so 80 over 100 times 77 is equal to, I don't know how much. They use this. Oh, what's this one? N, P out, P in, and this means efficiency. Oh, what am I reading? Wait. Okay. They're giving you weird symbols al fadi. I think like when my head of when our physics teacher explained it, he used this formula as well. Basically, efficiency, it's this symbol. I don't know why. Okay, efficiency. How do you calculate efficiency? Efficiency is how much you're actually getting, right? So it's how much you're actually getting divided by how much I'm actually putting in, right? So let's say مثلا I put in 100, I only got 80. So how much am I actually using? I'm using 80 over 100. But remember, we wanted the percentage, right? So you multiply by 100%. Okay? So it's always out over in times 100%. So basically, they use this formula. If it comes written, you need to use this formula. Okay? I doubt it's gonna come in written. Anyway, so power output. So they said power out. How do you get it? Power out is equal to obviously power in, efficiency times power in over 100%. So it's gonna be P out is equal to 80% times P in. P in is, we're inputting 77, right? Over 100%. And I think these percent with percent cancels, 0 with 0. And you're just going to get 0, basically, yeah, 62, 80, whatever. It's, by the way, this will get you the same answer, huh? But they want you to use the formula that we didn't take. Okay, then they said give two reasons why the efficiency of the loader may be less than 100%. This is like, these are, this is an IGCSE question. Obviously, you can say heat dissipated in wires or whatever, heat friction, okay? So, in the wires, heat dissipated due to friction, or in the wires or whatever. Determine the time it takes to raise a weight of 1000 newtons by 1.8 meters using this load. I know the first thing I'm thinking of is energy is equal to power times time. Because we have power and we're talking about newtons, so we're talking about a force here. Time, well, I don't know. I said time and we have power, so the first thing I thought is energy is equal to power times time. Okay. Uh, the first thing you can say energy. Okay, it's in joules. But what equation do I have for energy? Am I gonna use maybe, obviously not power times time. Maybe we might use I don't know, MC delta T, but you're gonna say, oh, top, where's the C? Where's the M? We don't have that. Okay, good point. Don't confuse. Also remember that energy is actually equal to work, which is equal to the force times the distance, which you're required to do from previous years. Or you can say energy is equal to the weight is equal to mgh, and mg is actually the weight, right? Energy is equal to, wait, what did I write here? Mgh, yeah, W equal mg, work here. Okay, work is mgh, right? So you can use mgh. Mg is the weight, 1000, and the h is 1.8. So you can either use either of these, because the weight is actually considered as a force and the distance is actually the height. So it doesn't matter. So I'm going to use that mgh is equal to the power, which we said the efficiency after the 80% efficiency, how much was it? 62. So 62 times the time. With the mass times g is the weight, so 1000 times 1.8 equal to 62t. So you divide by 62, 1000 times 1.8 divided by 62, and you get 29. So approximately, you could say approximately 29 seconds. Oh, they just, so they just gave me the formula I didn't solve. Okay, thank you. 65. I think my answer is correct. 65 is this question refers to quantities and data shown on the circuit below. Determine the equivalent resistance of the circuit. Okay, so our equivalent, let's see, what do we have? We have a parallel one and we have a series one. So first you find the parallel one and then you add it to the series one. Okay, to find the parallel one, you can use product over sum. I'm going to consider this as R1. If this was written, call this R1 and call this one R2. So I would say is equal to R1 plus R2. Then you would say R1 is equal to the product over the sum. Or you can use 1 over 20 plus 1 over 20 and flip it. عادي. So here you're going to get 400 over 20. You're going to get, hold up, 4 over 40, sorry. Over 40. So you're going to get 10. Okay, so R1 is 10. And we're going to add that, what? To R2. So 10 plus 40 is equal to 50. So our equivalent is 50. Determine the current through point D. Let me erase this. Let me check my answer because you never know these questions. A, is it 50? Yes. Okay. Through point D, the current through point D. Okay, so look here. For point D, this is, don't think about the nodes before the resistor so it doesn't fall under it. Think about it, that doesn't work in physics. Think about it in no, it's outside the parallel stuff. So if it's outside, it falls under I total. Remember, when you find the I total, it's V over R total. And R total we found in part A to be 50. So I total is equal to V3 over 50, which apparently is 0 0.6, I think. I think it's 3 divided by 50, 0 0.06, sorry. Okay, ampere, which is correct, but they put in the answer key, they put it as milliampere. So you can just make it 60 milliampere. Okay, so 60 milliampere through point A and through point C. So here's how they did it. So they said, okay, the current is coming as 60 milliampere. The bulbs are identical because it's the same bulb here. Okay, because they have the same resistance command. They have the same resistance. So since they have the same resistance and the same voltage, so they should also have the same current. So if it's 60, it's gonna split off into this current here, and it's also gonna split off into this current over here, right? Since these currents are identical, you can say 2I is equal to 60, so I is equal to 30 milliampere. So also through point C, it's gonna be the same thing, also 30 milliamp. Determine the PD between A and B, okay, and between D and E. Now, since we have the current, and we also have resistance, it's very easy to find the PD. Remember, V is equal to Ri. So between A and B, you have our current, which is 30 milliampere, and we have our resistance, which is 20. So 3 times 20, you're gonna get 60 millivolts. Okay. If you want to keep it, if you want to make it 30, you want to change it to 0.03 and then divide. عادي بس I kept my answer in milli. I'm pretty sure they should. One, two, three. How? How يا أخي how man how. Sorry, it's 600. I forgot the zero. 30 times 20 is not 60. Okay, between D and E, so between these 2 points, some people can use resistance as 40. Why not 40? Oh, wait, let me just make sure before I'm bullshitting. Ah, okay, basically use 40. So let's take it as a rule, okay? Currents, current is the same in the circuit, but the resistance doesn't necessarily mean if the total resistance is 50, yani the potential difference between these two is gonna be falling under 50 ohms. No. So the resistance depends on where you are. But here, if you're talking about the current at point D, it's falling across the total resistance. So if you're talking about the voltage between point D and E strictly, because we said between D and E, over here it's the resistance is 40. Okay? So you're gonna use V equals Ri, the resistance is 40. The current we said in part A over here it's 60 milliamps. So 60 milliamps, and you're gonna get 2400 millivolt. Let's just put it in actual volts, 2.4 volts. Okay, you divide by 1000. Oh my god, this chapter doesn't want to end. 66. A metal sphere is positively charged and placed on an insulating stand. An initially neutral metal ball hanging from a thread is brought near the sphere. Describe any change in the charge distribution as the metal is brought near the sphere. Obviously, negative charge will accumulate on the positive side of the sphere. Electrons move towards the side of the ball that faces the sphere. Obviously, negative charges or electrons, same thing, right? Because انت عندك البوزيتيف هيدا the so the positive negative so what positive negative the negative charges will accumulate over here, right, close to the positive sphere, and for that reason what's gonna happen, it's gonna attract. The ball is now very close to the sphere, right? So the ball is gonna attract. Describe its subsequent motion. The subsequent mean before or after? I think it's after, right? The ball tilts towards the sphere, touches, and yeah, after. So what's gonna happen? It's gonna attract now since the negative charge accumulated. It's gonna touch the sphere. What happens when you touch the sphere? It's now gonna steal the positive charges. Okay, so this ball will now become positive, and since you have two positive objects, it's gonna now repel backwards, right? Okay, very easy. Provide explanation for them. Oh, I just explained it. So initially, the induced charge leads to an attraction, right? We call it an induced charge because it's not actually a negative ball. It's just induced because the negative charge is accumulated on this side. So leads to an attraction force between the sphere and the ball. Once the objects touch, this object here, Allah, it's gonna look like this, صح? Okay, and like a negative charges. When they touch, it's gonna lose the negative. Why? Because this positive object attracts negative charges. So negative charges, they're gonna leave. What happens when negative charges leave? The ball is gonna become positive. What happens when you now have two positive charges? It's gonna go back. Okay. So it leads to an attraction force. Once objects touch, the electrons move into the sphere, making the ball positive. Once both objects are positive, they repel. So I basically explained it in my own way. That's chapter 2. I don't know, 2.23 done. Thank you so much for watching. Good luck.